Lesson 2, Quadratic Inequalities in 2 variables. So we can express a quadratic inequality in 2 variables in one of the following 4 forms. Y is less than ax squared plus bx plus c. Y is less than or equal to, y is greater than, or y is greater than or equal to ax squared plus bx plus c. A quadratic inequality in 2 variables represents a region of the Cartesian plane with a parabola as the boundary. So in the last lesson we were looking at lines, this time parabolas. The graph of a quadratic inequality is a set of points, again x, y, that are solutions to that inequality. So consider the graph of y is less than x squared minus 2x minus 3. The boundary is the related parabola, y equals x squared minus 2x minus 3. And since the inequality symbol is less than, points on the boundary line are not included, and so it's a dashed line. To determine which region is in the solution region, choose a test point from either above or below the parabola. So if we try the point 0, 0 and substitute it in to our inequality, we end up with 0 is less than 0 squared minus 2 times 0 minus 3. So 0 is less than, this is 0, 0, negative 3. 0 is not less than negative 3, and so the point 0, 0 is not in the solution and therefore is not shaded in. Let's try one where we have to create the graph. So graph y is less than negative 2 x minus 3 squared, all squared, plus 1. To graph this, we know that our vertex is at the point 3 and 1. So we can graph that point. So over 3, up 1. And now we need to be a little bit more specific on these than what we were earlier in the year when we were graphing these quadratic functions. And so let's find our x-intercepts. To find our x-intercepts, we can let y equal 0. So we have 0 equals. We'll work with an equal sign just because it's less confusing. Negative 2 x minus 3 squared plus 1. We can solve this using our square root method. So we're going to subtract 1 to the other side. Equals negative 2 x minus 3 squared, all squared. Before we can take the square root, we need to get what's being squared by itself. So we're going to divide both sides by negative 2. So negative 1 divided by negative 2 is just 1/2 equals x minus 3 all squared. Take the square root of both sides. Remember, when we're taking the square root, it becomes plus or minus, which is where our 2 intercepts come from. 1/2 equals x minus 3. Add 3 to both sides, and we have 3 plus or minus root 1/2 equals x. So that gives us our x-intercepts. Now those are pretty confusing because I'm not sure that anybody could pick out where 3 plus 1/2, the square root of 1/2 is. And so if we change those to decimals, we end up with x being approximately equal to 3.7 and 2.3. So I know on my graph, 2.3 is going to be about here, 3.7 is going to be here, and so my parabola opens down. Because it's a less than and not less than or equal to, I shouldn't have drawn it with solid lines, I should draw it with dashed lines. So I know that that is the rough shape of my parabola. I now need to decide what region I want to shade in, and so we need to test the point. Now this is where we need to be careful on the point that we pick. I know that the point 0, 0 is not close to that boundary region. I know it's very much outside of it because I know my x-intercepts. So let's test 0 and 0. I end up with 0 is less than negative 2 times 0 minus 3 all squared plus 1. So 0 is less than negative 2 times negative 3 squared plus 1. So 0 is less than negative 2 times 9 plus 1. 0 is less than negative 18 plus 1. Well, negative 18 plus 1 is negative 17, so this is not true. So that tells me that my solution region does not include 0, 0, and so must be the region inside that parabola. Part B asks us to determine if the points 2 and negative 4 is a solution. And again, to do that, we're going to substitute into our inequality. So y, or negative 4, has to be less than negative 2 times x, which is 2, minus 3 all squared plus 1. So negative 4 is less than negative 2 times negative 1 squared plus 1. So negative 4 is less than negative 2 times 1 plus 1, or negative 4 is less than negative 2 plus 1. So negative 4 is less than negative 2 plus 1 is negative 1. This is true, and so the point 2 and negative 4 is part of my solution. So 2, I'll use a different color, 2 and negative 4 is part of my solution, and that agrees with what my graph says. So it's always a good check. Now we're going to graph y is greater than or equal to x squared minus 4x minus 5. So let's start by graphing y equals x squared minus 4x minus 5. Again, the easiest place is to find your vertex. We can complete the square on the vertex, or we could use our formula that p is equal to negative b over 2a to find the x coordinate, and then substitute back in. I'm going to complete the square. So y is equal to, remember completing the square, we're putting the first two terms in our bracket. The second term is outside. Then we want to divide that middle term by 2 and square it. So negative 4 divided by 2 is negative 2. Squared is positive 4. If I add in 4 inside, I need to subtract 4 outside. And so I end up with y equals, that trinomial will factor into x minus 2, and negative 5 minus 4 is negative 9. This tells me that my vertex is the point 2 and negative 9. So we can graph that. 2 and negative 9, 1, 2, 3, 4, 5, 6, 7, 8, is way down here on the bottom of my graph, and I know that it opens up. To find my x-intercept, so I have some idea of how wide those arms are, I'm going to put in 0 for y and solve this quadratic equation. So bringing 9 over, I have 9 equals x minus 2 all squared. Take the square root of both sides. The square root of 9 is 3, so it's plus or minus 3 equals x minus 2. Add 2 to both sides, and I have 2 plus or minus 3 equals x. So one solution is x is equal to 2 plus 3, or 5. And the other solution is x is equal to 2 minus 3, so x is equal to negative 1. Drawing those points on my graph, x equals 5, 1, 2, 3, is this point. X equals negative 1 is this point. My inequality was y has to be greater than or equal to, and so they're solid lines this time. Sorry, that should have actually gone through that point. Let's try that again. Close enough. and there. So now we want to test a point. I know that the point 0, 0 is definitely inside my parabola, so let's try that one. So testing 0, 0 gives me 0 is less than or equal to 0 squared minus 4 times 0 minus 5. So 0 has to be less than or equal to, these two give me 0, negative 5, which it is not. Sorry, this says 0 is greater than or equal to negative 5. 0 is bigger than or equal to negative 5, and so the point 0, 0 is included, and so I want the region inside of that parabola. Our last question for today is again a word problem. It says determine the quadratic inequality that defines the solution region. You can use a parabolic reflector to focus sound, light, or radio waves to a single point. A parabolic microphone has a parabolic reflector attached that directs the incoming sounds to the microphone. Describe the region that can be covered with a microphone if the reflector has a width of 50 centimeters and a maximum depth of 15. So let's draw a picture of what this would look like. I'm going to put the vertex of my parabola at 0, 0. And so here's my parabola and my reflector. I know that it has a maximum depth of 15. And so the distance, these should actually be ending points. The distance from here down will be 15. I also know that the width of it is 50, which means that it goes 25 in each direction. And so this point would be the point 25 and 15. We need to write an inequality for that. And so we're going to use y equals a x minus p squared plus q. Because I've picked my vertex to be at 0 and 0, there is no p and q in this case, or there's 0 and 0, and so this equation just becomes y equals a x squared. To find a, I can substitute in this point that I know, so y is 15 equals a times x, which is 25, all squared. So 15 equals 625a, or a is equal to 15 over 625. 15 over 625 will reduce and give me an a value of 3 over 125. So my equation of that boundary is y equals 3 over 125, which is my a, times x squared. I need to decide now what inequality sign needs to go in there. And so let's test a point. Let's test a point that's on my y-axis. And so we are going to test the point 0 and 3. If I test 0 and 3, substituting it in, I have 3 equals 3 over 125 times x, and x was 0. 0 squared is 0, and 0 times anything is 0, so I have 3 and 0 that I'm comparing, and so my inequality sign needs to go this way. And it is an equal to sign because the sound that hits that reflector is also included. So my inequality becomes y, and instead of equal to, it becomes greater than or equal to 3 over 125 x squared. I know that the region in here is what is included because the sound doesn't actually reach the outside. If I look at my domain for this question, my domain in the x direction, the smallest value for x that it can be is negative 25. The The largest is positive 25. My range can go from 0 to positive 15. We're only looking at that specific point in this case. So those arms of the parabola actually stop because they are a reflector, not carrying on infinity to infinity.